This is Farmer John, and this is his farm. Unfortunately, Farmer John is getting old and needs some help maintaining his farm, so we are building him an agent that can navigate the farm and help plant and harvest crops much better than any human worker could, or at least that's the plan. In order to train the neural network, we need to take the contents of the farm and convert it into an integer array that our neural network can comprehend. We pass that into the agent's neural network, which looks like this, and we get an output as an array that looks like this, with each index representing an action. The agent chooses which action to do based on which value is 1. Our agent has 200 steps to find the destination. At the end of each mission, the agent is randomly teleported and given a new destination. A mission ends when an agent is directly adjacent to the destination block or has exceeded the step limit. At the beginning of the training, the epsilon is relatively high, starting at 1 and slowly tempering towards a value of 0.1. This causes a lot of random movement early on, which is indicative of the agent exploring the environment. Let's pull up a heat map for a destination that the agent travels to get a better idea of where the agent likes to travel and hang out as he's trying to navigate to the destination. As we get a few thousand missions in, we can see that the agent has learned how to navigate to some of the plots, but the paths are not very efficient. Here we can see the graph success of the agent for the destination 4-4 throughout the training. By seeing this, it is obvious to tell that the agent is learning. However, it does appear that the agent has a difficult time navigating to any plots with an x-coordinate value of 10, 11, or 12. By looking at the heat map here, we can see that for these values, the agent likes to stay and wander in the center of the farm, but gets relatively close to the final destination, and every now and then will correctly navigate to the destination. This tended to be a common theme between all plots with an x value of 10, 11, or 12. The team has some ideas on how to improve upon what we have right now, and we are very excited to start testing and implementing our new ideas. As we finish with the pathfinding neural network, we'll be moving on to a much simpler network that will handle the decision-making process of where the agent should navigate to and what crop the agent should plant. So stay tuned for the final report.